Hello, everybody. Welcome to our second ArcESB webinar in a series of 3, where we're covering an end-to-end EDI integration. My name is Matt. I'm here with Ron, and we are excited to jump right into what ArcESB can do. But first, right here at the front, I want to give you a sense of what you can expect over the next 30 minutes. So we're going to start with a brief presentation where we introduce ArcESB as a whole. We talk a bit about the use case that we're addressing here in the series, and we provide some information about what we talked about in the last webinar. Right after that short presentation, we'll jump into a live demonstration of a backend integration as part of this holistic EDI integration, specifically dealing with SQL Server. Then right after that live demonstration, we will open up the floor for Q&A. So if during the rest of the presentation you have questions, not sure about something, need a little bit more detail, do feel free to leave those questions in the Zoom chat and we will address them at the end. Now, I want to get Ron in on this conversation. And Ron, last time we introduced a fictional company and their fictional use case to help provide some context to what we're addressing here in this series. Do you mind reminding us of this fictional company and what they're trying to do?
Sure thing, Matt, and thank you very much for that introduction. A very good afternoon to all of our viewers. My name is Ron, and we're super excited to show you some of ArcESB's integration capabilities. So let's dive right in. For those of you who were with us for the last webinar, you might remember that we discussed an example company that we named Wholesale Suppliers. Now, Wholesale Suppliers is a manufacturing business that would like to sell its products on Amazon's platform. As many of Amazon's vendors do, they need a system to exchange business documents like purchase orders and invoices with Amazon. And since they're a very large company that has a large volume of transactions, they would like to do this over an AS2 connection to ensure that everything happens automatically and reliably. Now, Amazon invited wholesale suppliers to join their Vendor Central portal, and they were able to register themselves up there and get the requisite information from Amazon to set up an AS2 connection. But that doesn't encompass their entire use case. They actually need to integrate the data that's coming into their system from Amazon to their backend system, which in this example is a Microsoft SQL Server. So in a sentence, their use case can be summed up as so. Wholesale suppliers needs to receive 850 purchase orders from Amazon and insert them into a SQL Server database. They also need to extract data from the same database to send back to Amazon in the form of 810 invoices. Now, as Matt mentioned, this is the second webinar of a 3-webinar series, and right after the webinar is over, we'll be able to send you both the fully recorded first webinar as well as the fully recorded second webinar for your record. But Matt, for those who perhaps were not with us for the last time, let's go ahead and recap the first webinar very briefly.
Certainly. So in the last webinar, we did 2 main things. We gave an overview of ArcESB as an application, and we configured an AS2 connection with Amazon live. So as an introduction to ArcESB, we talked about how it's a web application that you can deploy anywhere. We briefly touched on each of the 3 major categories of features that it has, and those categories are managed file transfer, data transformation and mapping, and backend integration. And then finally, we talked about the flows page and the connectors in ArcESB. The connectors are a library of tools that you configure in the flows page to create an automated business workflow. Once we were done introducing ArcESB, we configured an AS2 connection live, and we did that in 2 steps. First, we configured a local AS2 profile in the profiles page of ArcESB. Then we configured an AS2 connector in the flows page of ArcESB with the details that Amazon provided. So at this point, we have a working AS2 connection with Amazon. We can send and receive those EDI files, and we're ready for the next step in this integration. In order for us to know what that next step is, Ron, why don't you talk through the general shape of this flow at a high level?
Sure. So this is obviously a very common workflow that we see with a lot of customers and users. And I personally like to abstract this use case into 3 general modules. First, I like to think about the front end of the use case, which I call the AS2 module. And this module involves exchanging files with the trading partner, in this case, Amazon, over AS2. We were able to set up an AS2 profile with an AS2 connector the last time we did a webinar. So let's go ahead and check that off our list. The second module I like to think about is the back end of this use case, which I call the integration module. In this module, we connect to a backend database or SaaS application and interact with that data source by extracting data from it and inserting data or perhaps updating data to its existing data tables. And this constitutes the subject of today's webinar. And we're going to do a live demonstration of this module and walk you through just how you can implement this in ArcESB. The third and final module I like to think about is everything in between these two ends. And I call this the data transformation and preparation module. This module includes translating EDI documents and mapping and preparing the data that is contained in them for further processing. And this will be the subject of our third and final webinar of this series. We're going to do a deep dive into data transformation and mapping and do a live walkthrough of all of ArcESB's translating and mapping capabilities. So do stay tuned. It's important to understand that we need to have both the front end, which is the AS2 module, and the back end, which is the integration module, sorted out before we can actually address the data transformation and mapping module. But once we have these three modules in place, which is our final end goal, we'll have a system in which data flows into and out of the system completely seamlessly and automatically.
All right, so before we jump right into the live demonstration of this database integration module, I think it's helpful if we talk about Arc's backend integration capabilities as a whole. So as I've mentioned, Arc provides its feature set through a suite of connectors that provide some sort of connectivity or data integration feature. The Arc includes a set of connectors that target specific databases, common databases like MySQL, SQL Server, Oracle, and SQLite. But we also have a general database connector where you can configure an ODBC or JDBC driver to connect to some database for which we don't have a dedicated connector. And the important thing to realize about each of these target databases is that Arc makes the approach, the concepts, the experience of integrating with each of these backend systems the same, regardless of what specific database you're using. In fact, ArcESB is so good at abstracting away the details of the backend integration that we can even integrate with application systems that aren't actually relational databases as if they were relational databases. So Ron, why don't you give us a little bit more information about how ArcESB can make that possible?
Absolutely. So in addition to the database connectivity that Matt just discussed, ArcESB also supports some robust application connectivity. And to demonstrate this, I'd like to introduce a company called CData. CData is the parent company of ArcESB and is a leading provider of standards-based solutions for data connectivity across the world. It has leading-edge connector technologies that simplify how applications like ArcESB can connect with critical business data stored in SaaS applications, APIs, databases, big data apps, and other such disparate data sources. And the ArcESB platform has actually been tightly integrated with CData through a set of drop-in drivers that enable users to easily extend connectivity to more than 250 enterprise applications. As you can imagine, this is super powerful. These drivers provide a simple way to connect to any of these data sources and allow the users to interact with application data as if they were interacting with any other conventional relational database. And this interaction that makes interacting with application data and database data almost identical is extremely powerful. And we're going to showcase that to you in a live demonstration just now.
Great, so it's time to jump right into ArcESB and show you the experience of integrating with your backend system. So Ron, why don't you give us a sense of what we're looking at right now here at ArcESB?
Sure. So as you might recall from the slide we had up just a few minutes ago, which had a high level abstraction of the workflow, we talked about an AS2 module, an integration module, and a mapping module. So what you see right now is basically the configured version of that AS2 module. We were able to go ahead and set up an AS2 profile for this example company wholesale suppliers, and we set up an AS2 connection that allows them to send files to Amazon and receive them from Amazon over a secure and reliable AS2 connection. So that's the AS2 module that's done.
All right, and as Ron mentioned, the next step in this is to establish the other endpoint of the flow, which is the backend integration endpoint or the database integration endpoint. And since we're working with a SQL Server database today, I'll go ahead and drag a new connector into the flow, the SQL Server connector. I'll give it a nice simple name here. And now the task is to configure this backend integration connector. So it's important to realize there are two steps for any database or other backend system integration connector. The first step is to establish a connection. And this is the fairly simple step that allows us to move on to the more complicated second step. But before we get there, let's go ahead and establish a nice working connection. So in general, configuring a connection in one of these database connectors requires configuring a connection string. And you can either specify this connection string as a list of enumerated properties, as you see here, or you can specify the connection string as a whole, like this. Now, in my case, I'm running the SQL Server instance on my local machine, so it's very convenient for me to use Windows authentication instead of the standard connection string authentication. So I'll go ahead and set this Windows authentication, and that allows me to just specify localhost as the server where the instance is running, and fill in the specific schema that I'm connecting to and test this connection. And so we see this green success banner, always a good thing to see, and this lets us know that our connection to the database is working. So that should allow us to move on to the next step in the configuration.
But Matt, before we do move on to that second step, let's demonstrate just how identical this connectivity is, regardless of which backend we're working with. So we have a few other connectors that we'd like to showcase here. As you can see on your screen, we have a MySQL connector, SQLite connector, Oracle connector that all connect to those specific databases. We also have a generic database connector that allows you to use ODBC or ADO.NET drivers to connect to different databases or custom databases. And lastly, we have that CData connector that I was briefly talking about, which allows you to leverage CData's driver technologies to connect to over 250 enterprise applications. Just to name a few: Salesforce, NetSuite, QuickBooks, amongst hundreds of others. But regardless of which connector you're using, you'll notice that the connection properties are largely similar or basically the same. So once you're able to go ahead and populate those fields and test your connection, you're connecting to the backend just like we did with the SQL Server. Matt, let's jump back into the SQL Server connector now. And you might have noticed that in all of those connectors that we were just browsing, all of them had the very same mapping segment right at the back end. And this concept of mappings is very important in ArcESB because this is how we actually interact with the data that's stored in the database or application system. As you can see, we have an input and output mapping section. And input mappings basically very intuitively represent insert or update statements. Basically, this is how you are going to be able to add data to or update existing data in your backend. Similarly, the output mapping represents select statements if we were talking in SQL statement terms. And that allows you to extract data from the tables that exist in the back end. And creating appropriate input and output mappings is basically where the magic happens here. That's where most of the work is done in these backend connectors by defining mappings that do exactly what you require it to do. It's important to understand that as soon as we go ahead and test that connection, you actually have access to all of the tables and views that exist in this database or application system. So Matt, let's jump in and start creating an input mapping for each incoming purchase order from Amazon.
Certainly. So as you mentioned, once this connection is working, the connector can automatically read all of these tables and views available in the database. That's why it's important to get that connection working as the first step. Now, the step 2 is creating our mappings. And since these mappings target a specific table, at this point we have to know a little bit about the data we're working with to know which table to select. So Ron, as you mentioned, the incoming data is 850 purchase order from Amazon. So I know that that's equivalent to my sales order table, and that's where I want to insert data. But there's an extra wrinkle here, which is that the sales order has two separate tables. There's the parent sales order, and then there's the sales order line items. So I need to know a little bit about the relationship between these two tables to proceed with my mapping. I know that line items are a child of the sales order table. In other words, each line item in a sales order belongs to some parent sales order. And when I'm creating an input mapping, I always want to start with the parent table. So at some point, I'll circle back around and add these line items to my mapping. But to start, I'll select the parent table, which in this case is sales order. And this brings up the input mapping editor. And there are a few features of this input mapping editor that I want to briefly cover before we continue. The first thing you'll probably notice is these set of checkboxes that correspond to each of the columns in our target database table. And if I wanted to ignore any particular column, I could always just deselect it here. But for the sake of simplicity, I'll keep all of these columns selected. The second thing you might notice is this upsert logic up here at the top. So upsert is a simple concept. When you're inserting data into a database, you're probably either inserting or updating, and the connector needs to know which to do. This combination of insert and update is what we call upsert. So by default, and most of the time, you'll use the primary key column to determine whether you're updating or inserting. However, sometimes you want to have more custom logic for when to update an existing row. So let's say that I know the customer's phone number, for example, is always going to uniquely identify a record in my target database. And if I'm submitting a phone number that already exists in the table, I don't want to insert a new row. I want to update the existing record. In that case, I could select the appropriate column, which in this case would be customer phone for this example, to let the connector know that it should check this column before determining whether to insert or update. And if you need even more granular control, you can perform your own custom SQL query to determine what column to select for this upsert logic. But as I said, I'll be okay with this default behavior of using the primary key to perform these inserts or updates. Now, the last feature that I want to cover here circles back to our question about the two tables we're inserting to. There's the sales order table, but then there's also the sales order line items table. So we can see that we have the sales order table covered here, but I want to add that child table, which is the sales order line items. And I can do that with this add button up here in the left and select the child table that I want to add to this mapping. So I've selected the line items table as a child here, and you can see this parent-child relationship reflected in the tree browser up here on the left. And this means that every time that I'm inserting data that is a sales order, I'll be inserting child data, which is line items associated with that sales order. Now this default behavior here in the input mappings editor is all that I need for this example. So without any further ado, I'm happy with this parent-child relationship. I can go ahead and create this input mapping to insert data into these two separate tables.
Fantastic. Thanks, Matt. Let's go ahead and open this up in the XML code viewer to show our viewers exactly what's happening behind the scenes here. So as you can see, there's this XML structure that the graphical interface that we just used to create this mapping, this is the XML structure that was a direct result of that. And as you can see, the XML structure mirrors quite perfectly the parent and child table relationship that Matt was just discussing, because we can see a parent element here for the sales order table. And then if we go further down, we see a child element for the sales order line items table. Now you might be wondering, why are we discussing an XML structure here? And it's very important to understand that Arc uses XML as the primary data modeling format across the entire application. So regardless of whether we were discussing data mapping or data integration, XML is used as a kind of a common data format across all the connectors. So this connector, the SQL Server connector, expects to receive information that it needs to update to the SQL Server database in this exact XML format. So when you're preparing your data to be inserted, this is the format that you're going to be using as a template. And I think there's no better way to showcase this than Matt. Just let's walk through an example here. Let's look at some example data and go ahead and push that into the database.
Certainly. So I've prepared a sample input file, and it looks like this. And you should see now that the XML structure of this input file matches the XML structure of that input mapping we just created. We've got this sales order table, and we've got this sales order line items table as a child of it. Now, one thing that might stand out here is that the sales order line item structure repeats. There's two of these, which corresponds to two separate line items in this same sales order. And that's not a problem. This repetition of structures is perfectly handled by the connector. It will use two separate inserts to insert both of the line items. So long as the XML structure, the hierarchical relationship is the same, the connector can detect these multiple sets of inserts just fine. So now I'll go ahead and go to the input tab of this SQL Server connector that we've been working with and upload that file I just showed you as a test input file. Now, if this connector were part of a larger configured workflow, I wouldn't have to manually upload and send this. But to give you a sense for this demonstration, here we'll send, which in this case means inserting the data into the database. Now, really quickly, I'm going to hop over to SQL Server Management Studio. If you haven't seen this before, it might look a little bit confusing, but this is just to show you that the data was actually inserted into the database. Here's SQL Server Management Studio. As you can see, I started with an empty sales order table, and I'll very quickly just execute a simple select statement so we see our new sales order that we inserted. And second, I can show you that this same insert inserted two different line items. So again, we started with an empty line items table, and that one insert put both of our line items here in the table. So hopefully that live demonstration gives you a sense of how that XML file gets turned into a SQL insert query.
Awesome. Thanks, Matt. So I realize that this is a lot of information coming out very, very quickly. And I do realize that some of our viewers might have questions. So I just want to encourage everybody, use the Q&A section and go ahead and send some questions in. We already have a few questions that I think will be worth answering, Matt. But before that, I want to do a quick recap of everything that we've just discussed. So we talked about this use case and broke it down into modules. And we said today we're going to be addressing the integration module. We showed you the SQL Server connector and just how easy it is to connect to a backend SQL Server database. But we actually extended that and showed you that it's equally easy to connect to any other database or any other SaaS enterprise application as well. We talked about input and output mappings and how we use an XML structure to communicate with these backend data sources. And we walked you through just how to do a very simple input mapping with a live example. Matt, before we move on, I have a question here coming from a user. They're asking about the SQL Server connector and the fact that it's not in their version of ArcESB. Would you like to address this?
Certainly. So you might have noticed when I dragged this SQL Server connector into the flow, it actually came from this other section down here. And so it's important to point out that some of the connectors that ArcESB supports comes prepackaged with the download. They're embedded in the application. Some other connectors require an external download, and that's a simple process of downloading it for free from our website and running a simple installer. And it's worth bringing up, I guess, at this point that ArcESB has an open architecture. So if you want to develop your own connectors that fit our very simple file in, file out structure, you can do that as well. We're coming out with an SDK later to develop your own connectors. And these are simple modules that you can plug and play, add to your custom business needs. So the fact that the SQL Server isn't showing up in your particular list of connectors simply means you'll need to download it from our website. And if at any point you want to develop your own connectors for your own needs, you can do that coming soon.
Just to reinforce what Matt just said, this just emphasizes the open architecture of the entire application. We have this library of tools that we call connectors, and once the ability to create connectors is publicly released, we'll be able to develop all kinds of connectors, and you'll be able to install custom connectors that do specific things that you need them to do as well. Matt, one more question, I think, before we move on.
Sure.
A nice question from a user here. They're asking if there can be more than one mapping in one connector.
Yes, okay, great question. So for this demonstration, we are just using a single input mapping here, right? It demonstrates the concepts at play. I can always simply add a new one and pick again from this list of tables that the connector is dynamically reading from the target database. If I had multiple different input mappings that I wanted this same connector with this same database connection to use, I would just simply specify them here. And the way that the connector knows which one of these mappings you're invoking, for instance, when it processes an input file, is based on this XML structure that we showed you earlier. So this sales order element is indicating that this is an insert into the sales order table. So if I had multiple tables here, then the connector would know to look for multiple different parent elements here to determine which of these input mappings it should actually invoke when it processes an input file. And I know that might be a little bit hard to see just from explaining it. So hopefully that explanation is clear.
Fantastic. All right, Matt, before we move on to output mappings, we have a question coming in from Chris Mitchell. He wants to know if there's a way to massage data so that it matches a specific target schema. And Chris, I just want to note here that there are several ways to map, translate, massage data and use all kinds of specific custom logic to do that. And that's actually a very dense subject that we're very keen on showing, but we want to leave that for another webinar in itself because we think it deserves kind of its own platform. So that's something we're going to be addressing in great detail in our next webinar, which we will be announcing very shortly. Matt,
Great.
should
Yeah,
we proceed?
I think we should. And Chris, you're touching on an important point here, which is, hey, I understand this XML structure is important. How do I get my data to look like that? And that's exactly the kind of question that we'll be answering in the third webinar in this series. So thank you again for Chris for foreseeing that use case. All right, let's move on to output mappings, which are conceptually very similar to what we've just done with input mappings, but as you might expect, deal with extracting data from the database rather than inserting it. So the same process occurs. We want to create a new output mapping. And if we recall, wholesale supplier's use case isn't just about inserting the purchase order data that it gets from Amazon. It also wants to respond to Amazon with invoices for that purchase order. So we don't just want to insert data into the database from our purchase orders. We want to extract data from our database to create an outbound invoice. So I'm going to add a new output mapping here that corresponds to that business need. And now we know we want to get invoice information out to send out to Amazon, but once again, we have the same question of, okay, but there are two invoice tables. There's the invoice table, and then there's the invoice line items table. What do I map against? And the answer is, once again, the parent table. So I know that the line items belong to a particular invoice. So invoice is the parent here. So I'll start my mapping with the parent table invoice, and I'll circle back around to the line items later in the mapping. All right, so we've got the output mapping editor here, and it looks fairly similar to the input mapping editor, but there's a slightly different feature set corresponding to the slight differences between input and output. So I want to briefly cover those here. Now, you'll probably once again notice these checkboxes for each of the columns. Once again, you can ignore a particular column if you want. In this case, I'll just keep everything selected. The second major feature that I want to point out here is this filter box. So this filter box allows you to establish rules to filter the output you're getting from the database. So let's say, for example, I wanted to only pull out invoice information that was, the invoice currency was US dollars, for instance. I can easily do that by adding a rule here in the filter box. And I want to select the column that I should check for this rule, which in this fairly silly example is going to be currency name. And let's say that the US dollars code is USD. And simply by inserting these 3 bits of information, this is adding a filter so that I'll only ever pull out invoice information for US dollars invoices. Now you can see that this is actually updating the query we're building underneath. So these filter rules are a nice, easy GUI way of creating output filters, but you can always see what SQL syntax this is actually referring to down here at the bottom. And in fact, if you have a crazy, wacky custom query that you'd like to run that isn't quite covered by the features in the GUI, you can always enable this write custom query and just start writing SQL down here. The next feature that I want to briefly touch on is just the simple order by. So this is a simple way of sorting your information according to some column. If you want to sort your output data, simply select the column to sort by and ascending or descending here to add that syntax to our SQL query that we're building underneath.
Fantastic, Matt. Now we have some advanced features here that I'd like to talk about. And these advanced features basically address a real business need. To put it in this example's terms, it will help wholesale suppliers avoid processing invoices more than one time. So basically, there are many cases where you need to process only those records that either have not already been processed or have changed since the last time the connector was used to process records. So there are two broad approaches that I'd like to discuss here. The first being the use of a last modified date. Now, something to understand about these connectors that connect to backend databases, not just the SQL Server connector, but all the other connectors that we just showed you, is that they store the time that they were last used to check the database or application for records. And if there's a column in the table that you're querying that stores a date time value for the last time a record was modified, the connector can actually compare that date time with the date time it has stored and see if the record is new or has recently changed. So you can use this feature that Matt just checked off to use the last modified time column as the data type and process only those records that have been updated after that time. The second approach here is the use of a flag or Boolean column, which is very simple. This column is basically a simple column that stores a 1 or a 0 to indicate if the record has been processed. So we'd obviously like this connector to skip records that have a 1 in there so that we don't process records that are already processed and pull records that have a 0 in there. So there are two simple steps to accomplish this. To ensure that I only pull unprocessed records, I would need to add a filter or a rule here, like Matt was just discussing, that checks the processed column to check that we only want to get those that are unprocessed. So those where the processed column equals 0. Now the second step here involves updating this column so that each time we actually process a record, we go ahead and indicate that, yes, this has now been processed. So there's that second feature here where we can update the processed column with the value of 1 when rows are processed successfully. So we just talked about two broad approaches, using a last modified time and using a flag or a Boolean column to process unprocessed records only. Obviously, you can use whichever method you find beneficial, but for this wholesale suppliers use case, we're going to go ahead and stick with the Boolean column method.
Great. So there's one last thing to talk about here for these output mappings. We've ensured that we're only ever going to pull the data for a particular invoice once, but we still need to ensure that we're pulling the line items for an invoice. If you recall, we have two different tables that we actually want to pull data from, this parent invoice and then the child line items. So the process for adding a child table to this mapping is the same as the input mapping editor. I'll use this add button and simply select the appropriate table. And once again, you can see this parent-child relationship displayed here in the browser on the left. Now, it's important to realize that I didn't overwrite all the hard work we just did to make sure the records aren't processed more than once. There are simply two tables as part of the same mapping, and I can swap back and forth as I want. With this new child table, though, we have an extra step we have to take here. So when we're pulling data out of the line items table, we want to make sure that we only pull the line items associated with the parent invoice. We don't want to just pull any line item data at all. We want to make sure that it is related to the parent table. So the way that we can establish this relationship between the child and the parent table is through this filter feature. So I want to go ahead and add a rule here in my filter, and now, or add a filter rule. And to create the correct filter rule, I have to understand something about the values in these two tables. Specifically, I need to know what value in my child table associates it with my parent table. So I happen to know that the invoice ID in my child table needs to match the invoice ID of my parent table for them to be talking about the same invoice. So I'll go ahead and add a filter that reflects this relationship between those two tables. So I'll start with the invoice ID column here in the child table. And now I want to check that that is equal to the invoice ID column in my parent table before I pull out that record. Okay, but how can I reference a column in my parent table? I can do that with this drop down here and setting this input text to ref. And that ref and this corresponding $ syntax shows that I'm referencing a column in my parent table according to this mapping structure. So now that I have this reference to my parent table, I know that the column I'm looking for is also called invoice ID. So I can simply grab that column from the drop down here. Now the resulting syntax is simply saying, only pull the invoice line items if the invoice ID for that line item is equal to the invoice ID for the parent invoice. And with this configuration, we've got everything we need for this output mapping. I can go ahead and create this here in the mappings panel.
Okay, wonderful. So Matt, let's go ahead and look at this in an XML format, just as we did with the input mapping. Now, as we can see, we can already identify the parent element here, just like we did with sales order with the invoice table. And the XML structure has a child element for the invoice line items table as well. Just a quick reminder, ArcESB uses XML as a common data format here. So every time we query this database for data, the connector outputs data in this exact XML format with a XML file that has the exact same XML structure. And this is important to understand when we talk about mapping and translating this data further on. Matt, let's see this in action, man. Let's go ahead and pull this database and get an example data, some example invoice data out.
All right, so to pull the database, I'll go ahead and navigate here to the Output tab. And once again, if this was part of a larger configured workflow with automation enabled, I wouldn't have to manually do this, but for the sake of this demonstration, I'll go ahead and hit this Receive button to manually query that database table. And I have just one record in my test table, and as you can see, that pulls out one XML file. So I'll go ahead and open up this single record that we just extracted from the database so you can see what it looks like. As it should be fairly clear from a glance, this is an XML file that matches the structure of that output format we just defined. It's got that parent invoice, the child invoice line items, and it's got all of the database information here in the XML content. Now, as Chris was alluding to, the question might be, okay, great, I can pull out information as XML files, I can insert information to the database from XML files. What am I doing with these XML files in the meantime? And that is exactly the question we'll answer in great detail in the next episode of this webinar series, where we talk about data transformation and mapping, and we fill in the gaps between this AS2 and the SQL Server endpoint in our flow. So Ron, that was a lot of information. You want to give us a brief recap before we head on into the Q&A session?
Sure thing. So for our viewers, we started off this webinar with an example use case that we broke down into 3 modules: an AS2 module, which we covered in the previous webinar, an integration module that we discussed today, and a data mapping and transformation module that we're going to be discussing the next time. In this integration module, we showed you how easy it is to connect to any backend and interact with them using input and output mappings. And we gave you a walkthrough of the kinds of features that are available to you in the input and output mappings specifically. We did a live demonstration with some examples, and now we open the floor to you for any questions you may have. We have some questions that have been coming in over the course of the presentation, so we'll start with those. But we're here to answer any questions, and we'll stay as long as needed. We're also going to be joined by a colleague, Michael Albritton, who will be joining us to help answer the questions as well. But for those of you who will be leaving us, thank you so much for joining, and we hope you enjoyed it. And look to our next webinar for some mapping information. Okay, Matt, we had a question come in from a user who was unfortunately unable to stay. His name is Saif Khan, and he was talking about the UI and whether he is capable of having more than one workspace for a flow. So he'd like to separate his trading partners in separate workspaces so as to not confuse them.
Certainly, yeah, that's a great question. So in order to understand this fully, it's important to talk about the difference between flows and workspaces. So this flow that I've been working in, you saw me drag it across to show some new connectors a second ago. You can think of this like Google Maps, where I can drag around and see different cities. And if I wanted to establish some arbitrary number of flows, connected flows in this canvas, I could do it like a bunch of cities dotting a Google Map canvas. If I want to have a little bit more logical separation between my flows, I can use this workspace feature up here in the top right. So these workspaces are, if you think of the analogy with Google Maps, these are like entirely separate planets. So if I navigate to a new workspace, it's going to give me an entirely new canvas that I can drag around, create new connectors, and so on. So you have a bit of a choice. You can create your different flows in the same canvas. You can split them up into separate workspaces. You can do half and half if you want to have several flows in one canvas and several flows in another. But we give you that flexibility to separate them up as much as you want.
Thanks, Matt. So, Saif, I hope that answers your question. Saif was concerned about confusing multiple different projects by putting them in one flow. Saif, we have a feature where you can create new workspaces an unlimited amount, and you can have as many different so-called planets, if we use the Google Maps analogy, to create different workflows in. So I hope that answers your question. Matt, we have a question from a Mr. Galinsky who's asking about inserting EDIFACT documents into the database. So Mr. Galinsky, as we mentioned, there are 3 kind of modules that we were breaking the use case down into. The AS2 module, where you're actually able to transfer files with trading partners. And in your case, that'll be EDIFACT documents. We have the integration module that we just showcased, where we can actually connect to the database and use mappings to input data into there. But that module in the middle, the data mapping and transformation module, now that's where you will find the answer to your question, which is we'll be able to translate EDIFACT documents into that XML common data format that we were talking about, and then prepare that so that it's ready to be inserted into the backend database. As Matt's showing you here on your screen, we have a list of EDI connectors that allow you to translate documents that are in specific standards, EDIFACT being one of them, X12 being another popular one. You can go ahead and drag and drop that into your flow, and you'll be able to convert incoming EDIFACT documents into XML, then prepare them with our mapping features that we will discuss in the next webinar so that they're ready to be inserted into the database. So I hope that briefly answers your question. If you'd like any more detail, please do reach out to us over email, support@ArcESB, and we'll be happy to go into even more detail. Otherwise, do look out for our next webinar where we're going to do a deep dive into all of this. Matt, Terry Brown is asking if he can map to JSON for API usage. Do you wanna address that?
Certainly, yeah. So we'll talk more about this sort of arbitrary mapping into different formats in this next webinar episode. The general approach we have is to use XML as a common format and then have a bunch of connectors that translate in or out of that format. So as a part of that last question, Ron just mentioned the EDI translation here, specifically Edifact. But JSON is just another one of those formats that you can translate XML into or out of. So we have this JSON connector here that you can drag into the flow, create a JSON connector. This will translate JSON to or from XML. So if you wanted at some point to extract data and then throw it into the JSON body of an API call, you'd pull it out as XML, you'd map it if you need to, and again, we'll go into mapping next time, and then you'd convert it into JSON with this JSON connector. So everything flows through XML, and then you just find the appropriate format that you want the data to end up in as one of our connectors over here.
Awesome. Thanks, Matt. I think that answers Terry's question. So we have another 3 questions here. Once again, we encourage you to send your questions in, but we do understand in the interest of time, we're going to keep our answers as brief as possible. Matt, Luca Amadio is asking if something goes wrong between the input and the output, how can he be notified?
Sure, so great question. So the first thing to realize is that errors are thrown here in the connector if something goes wrong, if there's a connection error, if, I don't know, there's a data type mismatch or something like that. An error will be thrown either in the input or output tab of the connector. But oftentimes you're not actively looking at these input and output connectors, especially once you've configured this full flow. And so what you want is general notifications from an application monitoring standpoint. And there's 2 general ways that we accomplish this. The first is specific to a given connector. So if you want to be notified of a specific connector's errors, what you can do is right-click the connector and show error path. And so we haven't shown much of this in this demonstration, but connectors can be connected together here in the flows page. And this show error path works as another connection specifically for operations that fail. So when the SQL Server encounters an error, if I have, let's say, a notify connector, if I want to be notified via email when an error occurs, this notify connector accepts some email address where it will send to a system administrator. And then I could simply use this show error path to connect the error for a particular connector to that notify connector. And this is how you get a connector-specific notification system. There's also a email send connector that will function the same way as this notify connector if you need a little bit more control over what kind of email you're sending and that kind of thing. So this is connector-specific notifications. If I want to go for I'll save this really quickly. If I want to go for a general application-wide notification setting, I'll find that in the profiles page. So this follows our general approach of things that affect the entire application are here in the profiles page. Things that affect individual connectors are over there in the flows page where I just left. So here in the profiles page, I can find under advanced this alerts section. So this takes the email address of a system administrator. I can set the interval and that kind of thing. So this advanced tab in the profiles page is where you'd go if you want to just know everything about any time an error occurs in the application. So those 2 approaches, these application-wide and the connector-specific, are generally how we handle those alerts.
So Matt, I think that answers Luca's question about being notified, but I think while we're on the topic, we can actually go and look at the transaction and application logs as well. So sometimes you might not choose to be notified, you just want to be aware of what's happening in your system, in the application. So we have 3 different logs here that you can kind of monitor. Transaction logs are basically for any file that's being processed by any connector across the entire application. You can filter them by file name or by connector specific or workspace specific stuff. And you can actually look at log files for each transaction, whether they're successful or unsuccessful. In addition to that, we also have the application log and access log, which application log is for things that are happening in the application itself. And access log is basically logging for requests coming into the application from outside of the network. So Luca, I hope that answers your question. If there's a follow-up, please do let us know. 2 more questions, Matt. Chris Mitchell asks, when sending data from a database, does the automation poll, can it be triggered via API? So two things we can talk about is the admin API and the automation settings, if you want to address that.
Yes, great question. Okay, so as I mentioned, typically in these configured workflows, you don't have to manually go and download files or insert files manually. What you want to do is you want to use the automation tab. So this automation tab is common to most of our connectors, and it allows you to make sure that you don't have to manually interact with the flow. In your case, I believe you asked about polling to receive to download according to an interval, and that would be handled with our receive automation. So this just means you set a receive interval, the connector knows at that interval to go look for it in your records to process that match the output mappings that you've configured and download those as XML files. If you need something a little bit more comprehensive than a simple interval, you can always use a cron expression. We give you some flexibility there. Send automation is relatively similar. It means you don't have to manually send any of your files. But what this will do is it will monitor a certain folder on disk for input files to arrive. And we haven't exactly talked about connecting the flow together because there's still a mapping and translation section in the middle that we'll cover in the next one. But when we have a fully configured flow, we'll have connections that look kind of like this. Now, not exactly like this, but kind of like this. And this means that files processed by one connector get passed along to the input folder of the next connector. And when you have send automation enabled, this means the connector will always be looking at that input folder, the send folder, for files to process. So a combination of enabling the send automation and connecting connectors in the flow means that the file data automatically passes through the logic of the flow without you having to interact with it. Ron, did I miss any parts of that question?
No, I think you did a great job, Matt. And one thing I want to stress upon is these automation settings aren't exclusive to database connectors. You'll find these automation settings across all the connectors in the application so that you can automate the processes across the entire workflow system and not just the database integration module itself. But I think we should address for Chris how we can use the admin API to trigger different connectors and make sure you have access to the application through an API and not necessarily only through the GUI.
Okay, that's a great question. So ArcESB comes with this nice shiny UI where you can do all your application management stuff, set up your flows, do everything we've been doing in this demonstration. But it's important to realize that underneath, all we're really doing is configuring folders on disk and the logical relationship between these connectors. And any of these operations we're performing here in the UI can be performed with a series of API calls. So we call this the admin API, which is an API we expose to give you the same access to the application and its configuration as you have when you're sitting here logged in and messing with the application. So in your case, you mentioned actually downloading files. You probably want the download file action as part of our admin API. We also have connectors and files resources if you want to, for instance, make an API post to create an entire new connector. The post to the connectors resource with all of the information about the configuration of that connector would do the same thing as actually creating the connector here in the flows page. So the important thing to understand is that these API calls are accessing the same underlying logic that we're using when we're manipulating the application via this UI. And if you need help with a specific API call that you need, or maybe you need a combination of a few, then we're always happy to help you build those. But in general, anything you can do in the application UI, you can do with API calls.
Awesome. Thank you, Matt. I think that's a great overview of the admin API as well. And we have one last question that's appropriately database specific. This user wants to know how they can implement stored procedures.
Of course, yes. So stored procedures are naturally the other side, the other common way of interacting with databases other than tables and views. And we've been focusing on tables in this particular demonstration. It's a good way of showing the concepts here. So let's layer on stored procedures to these same concepts. And the general interaction is going to be the same. So we're going to build an XML input and output template. And I'll go ahead, I actually have a test stored procedure in this simple test database I've been using. So I'll go ahead and actually access that so you can see what I mean. So first of all, stored procedures are different than tables in the sense that oftentimes they have both input parameters and they spit out output. So this is the function of this input and output tab. So if I am here in this input and output tab and I want to add a mapping, the connector will detect this stored procedure that I have configured in MySQL Server. So in this case, I just made a really simple get orders by customer name stored procedure. You give it a customer name, it spits out any orders associated with that customer. Not too complicated. If I had more configured, they'd obviously show up here, just like all of the tables would show up in the input and output mappings. Let's go ahead and select it. And now it's showing you the input parameters. Not really much to do in this screen. It's just letting you know what the input parameters are. As I said, this particular stored procedure takes a customer name, spits out any orders. So this customer is our input. Go ahead and create this. And now the important thing here is, just like those input and output mappings, all that did underneath, or what that really did underneath, is create an XML template of this stored procedure. So in this case, it should be a little bit familiar by now, having gone through a couple examples. We have the name of the stored procedure as a parent element. In the other mappings, those were the names of a table that we're inserting or selecting from. In this case, it's the name of the stored procedure. And we have the parameter, the input parameter, customer. So this is the XML structure of input files that the connector is expecting if it wants to invoke this stored procedure. Now, output from stored procedures is a little bit messier, because the output from a stored procedure isn't necessarily well defined in advance. So our output structure represents this by saying there may be some arbitrary number of result sets. There's maybe some number of columns that are returned. And so this might not be all that helpful if you're looking to figure out what your output data is actually going to look like. So to do that, I'd recommend using our very handy feature, this show sample data. So this is going to allow you to actually invoke the stored procedure with some set of test input. And so for instance, here, the only input parameter is customer. So if I type in a garbage customer name and execute the stored procedure, it would show you what XML the connector would spit out. And so since obviously there aren't any customers there, it's not returning anything. But you can use this to run some test queries against that stored procedure, see what that output XML would look like, and then use that test data as a template to map to or map from. So the same principles of using XMLs, using an XML structure as a template is the same between stored procedures and input and output mappings. It's just that the details might depend a little bit on your specific stored procedure.
Thanks, Matt. So I think that wraps up our Q&A section. As far as I can see, we have no more questions to answer. So just again, want to reiterate, thank you very much to all of the viewers who were able to tune in. I hope we've been able to give you a very good overview of what ArcESB's integration capabilities are. And if you have any specific questions about your use case, please do reach out to us. You know, we're always welcome hearing from our users and our customers. And we're eager to help you implement whatever integration systems that you might need any help with. So do reach out to us. support@arcesb.com is our email address. Let us know. We just got a question in asking about where you can download the recording of this webinar. We'll be sending it out over email once we're all done with the recording and we polish it up. So please keep a lookout for that. Thank you once again, and do tune in to our next webinar, which is going to be a deep dive into mapping and transformation along with EDI translation. That's going to be really awesome, and we can't wait to showcase what we have in store for you then. Until then, take care and see you soon. Thank you so much.
Thank you.